to take a look at some more practice with derivatives. So let's take a look at our first problem. We want to find the derivative of 3x plus 1 all over x plus 7 times 4x minus 1. So if I take a look at what's happening first here, I have the product of two functions. So I want to go ahead and use my product rule first. So if I want to find the derivative of this function, then my product rule says that I want to take my first function, 3x plus 1 over x plus 7, times the derivative of the second, which would be a 4, plus my second function, 4x minus 1, times the derivative of the first. So now, when I take the derivative of the first, my first function is a quotient. I know that my quotient rule says start with the denominator and square it in the denominator. Then I'm going to jump up top and I start with the denominator, x plus 7, times the derivative of the numerator, which is a 3, minus the numerator, 3x plus 1, times the derivative of the denominator, which is 1. So let's go ahead and distribute and combine like terms up top in my quotient. So if I do that, I'm going to have a 3x plus 21 minus 3x minus 1. So if I take a look at my two fractions, my first fraction, I'm going to go ahead and distribute that 4 into the numerator, because 4 is the same thing as 4 over 1. So we've got a 12x plus 4 all over x plus 7, plus we have a, if I take a look at what happens inside of my quotient, 3x minus 3x is gone, and 21 minus 1 is 20. So we're going to have a 4x minus 1 times 20 all over x plus 7 quantity squared. All we have to do now is clean this up a little bit. So to clean this up, I need to kind of find a common denominator. My first fraction is missing one of the x plus 7's. So let's multiply top and bottom by x plus 7. And I now have my LCD of x plus 7 squared. And then when I FOIL out my first fraction, 12x times x is going to give me a 12x squared. My outer terms and my inner terms are going to give me an 88x. And my last are going to give me a 28. And then I still have my 20 times my 4x minus 1, so plus 80x minus 20. So then I can go ahead and combine like terms and simplify things down, and that's going to give me a 12x squared plus 168x plus 8 all over my x plus 7 quantity squared. If you wanted to, you could factor out a 4 out of the numerator, and if you did that and you checked to see if it could be reduced any more, you'd be figuring out what multiplies to 6 and adds to 42, which isn't possible, so I can't factor my numerator, which means I can leave it like this, or I can factor out that 4 out of the numerator. Now, if I look at questions 2 and 3, they give me my function h of x in terms of either a product or a quotient of other functions, g of x and f of x, and they give me my values. So for example, question number 2, I want to find the derivative of h at 2. And I'm given that the value of f at 2 is 4, the derivative of f at 2 is negative 1. The value of g at 2 is negative 5, and the value of the derivative of g at 2 is 3. So what we want to try to do is take the derivative of h and then replace our x with 2. Now the first thing that I notice in my question number 2 here is that I have a 7/2 out in front. I have a constant. So I'm going to go ahead and choose to rewrite h of x as 7/2 times the product of f of x times g of x. So now I can go ahead and use my product rule on f of x times g of x, And then at the end, I can go ahead and distribute that 7/2. So let's go ahead and take the derivative of h of x. I'm going to leave that constant out in front. And I know that when I'm finding the derivative of the product of two functions, I'm going to take my first function, f of x, times the derivative of the second function, so g prime of x, plus my second function, g of x, times the derivative of f of x. Now I can go ahead and replace x with any value. Well, in this problem here, we want to go ahead and replace x with 2. So I want to go ahead and evaluate my derivative at 2. So I'm going to take 7/2 times f of 2 times the derivative of g at 2 plus g of 2 times the derivative of f at 2. And let's go ahead and plug those values in. So we're going to have a 7/2 out in front. So if I want f of 2 is 4 times the derivative of g at 2 is 3 plus the value of g at 2 is -5 times the derivative of f at 2 is -1. And that's going to give us a 12 plus 5 inside is 17. So if we have 7/2 times 17, that's going to give us 119/2. We could do the same thing for a quotient. So now let's look at problem number 3 here. We want to, again, find the value of our derivative at 2. So let's first take the derivative of h. This time, I have myself a quotient. So if I have a quotient, I know that I start with the denominator squared. So I'm going to take g of x squared in my denominator. Then I move up top and I start with my bottom function, g of x, times the derivative of the numerator. The derivative of 9 is 0, and the derivative of f of x is f prime of x. Minus, then I want to go ahead and take my numerator, 9 plus f of x, and multiply it by the derivative of the denominator, g prime of x. So now we can go ahead and plug in our values just like we did for 2. So we know that g of x is equal to -5. The derivative of f is -1 minus 9 plus the value of f of x at 2 is 4 times the derivative of g at 2 is 3 all over the value of g at 2, -5 squared. So that's going to give me a 5 minus 39 all over 25. So 5 minus 39 all over 25. And that's going to reduce down to -34 over 25. And that's the last of it.